So my name is Bas Moorkens. I work with Ordina as a competence lead of cloud platforms. And today I'm here because we didn't find enough speakers for join. And I had accidentally something cool I built. So today I will be talking about sending money through the blockchain via AWS Lambda. But I'm not a guy of big titles and words, so I rebranded my title to Sending Money Like a Hipster, which sounded fun. So, before I start, a quick show of hands. Who here has worked with blockchain before? Okay. Who has worked with Lambda serverless? Okay. So this talk was originally an hour long. I dumbed it down a bit, and I'll try to keep it high level because 15 minutes is not a long time. But if you have any questions about stuff that I don't really touch deeply here, just come talk to me afterwards, okay? So, what can you expect from this talk? It's more of a fun talk. It's basically just to give you guys an idea about some technologies that are coming up that we see that we could potentially use in the market in a couple of years maybe, but it's nothing really serious now. So just relax, sit back and try to enjoy it. The use case that I'm gonna be talking about. So for a hobby project of me, I built a web application a while back that was doing escrow payments with cryptocurrencies. For those of you who don't know what that is, that's kind of like a platform where users can buy and sell cryptocurrencies from and to each other without really dealing with an exchange like Binance or whatever, Coinbase. And at the end of that process, when a user has confirmed that the trade is done, he, of course, wants to withdraw his precious internet money to his wallet. So that's where my problem started a bit, because the web application, when you try to withdraw money to your account, you have to write a record on the blockchain. And blockchains are typically a bit slower than your average database or queuing system. So take, for example, PayPal. If you withdraw money there, they probably just insert a record in a database or on a queue, and poof, it's done. But on a blockchain, you have confirmation times, latencies, whatever. So it's a pretty shitty solution to do it like this. And that brings me with the main problem that users don't like to look at loading screens. I think some of you are familiar with it. You click on something and then it's 30 seconds of a circle. Not so much fun. So the blockchain that I'm using in this project is called Stellar. XLM is the ticker, and the currency is Lumen. And this is important because I wanted to highlight some features that we'll be using in the demo later on. So Stellar uses the Stellar consensus protocol to add blocks to the chain. So it's not like Bitcoin where you have whole countries mining coins. No. With Stellar you just have validator nodes that validate transactions. And when 66% of those validators agree that this is valid, it gets added to the chain. So it's a lot more ecologically friendly. And the byproduct of this is that we're done apparently. Okay. So consensus is reached every 5 seconds. That's important for later on. A second feature that's pretty important, and especially for developers, Stellar has a thing called Horizon, which is an API server that lives on top of the blockchain. So you can just use that server to do operations on the blockchain through REST endpoints. Or if you're really lazy, you can use the SDK. And I'm pretty lazy, so we'll be doing that. The tech stuff, so I talked about reaching consensus on the previous slide. What that means for us is every time you reach consensus, you can add a block. And on Stellar, it typically takes 5 seconds. So every 5 seconds you can get your money from the blockchain if you can get it in the current block. So the best case time is 5 seconds, but if there's a lot of traffic on your blockchain, it might go up. There are workarounds for that, but a bit out of scope here. So that brings me to this nice diagram I made, because I try to be an architect. On the left we have my EC2 server, which is running our web application. It's written in PHP. And so the web application here is sending commands to the blockchain, and that takes a lot of time. So we didn't want to do that. So I tried to make it more efficient. And I was thinking like, hey, I work a lot with AWS stuff, and serverless is pretty cool, so let's give that a try. So instead of waiting for the blockchain to confirm, hey, your transaction is added to the chain, we're now gonna put a record on an event queue, SQS in our case, and then we can give instant feedback to the user, hey, your request for withdrawing funds is processing. So the user gets instant feedback, instant gratification, so he's happy. And we just have to find a way to convert our message into a transaction on the blockchain. So I also thought about that. Can we do a microservice? Should we do a monolith? Should we do serverless? Whatever. But the code to actually make a payment is very, very small. We'll see that in a short while. And it doesn't have to be running all the time, so it was a prime candidate to put in a Lambda function. And that brings me to the following picture. I spent a lot of time drawing up that. So we still have our EC2 server with the main web application, but now instead of writing stuff to the blockchain directly, we put messages on an SQS queue. The SQS queue has a Lambda attached to it, so every time you receive a message on that queue, the Lambda function kicks off and says, hey, I gotta start working. The Lambda function uses AWS Secrets Manager to fetch the private key, because if you want to send money on the blockchain, you have to sign it with the private key of that account. And once it has that private key, we can actually make a payment on the blockchain. And possible steps after this is to put events on another queue or something, so the user gets feedback, hey, your request is processed. That's about it for slides. Let's look at some code and AWS stuff. This code is available on GitHub for those of you that are interested and are not bored out of their minds yet. Is it readable? Probably not in the back. The one and only Java IDE. So, God man zeg. Let's do it in another way. Voilà, problem solved. That's the DevOps spirit, creative problem solving. So I wanted to start with the POM from my little project and then go to the code. So I just wanted to show you guys that there's not a lot of stuff actually that needs to be added in order to work with Lambda and the blockchain. So I have a dependency for AWS Lambda, so we can access their utility functions. I have a dependency from the Stellar SDK, so we can interface with the blockchain. And I have two more dependencies. So to the AWS SDK, you have to include core whenever you're using something of AWS, so that's mandatory. And I'm using the Secrets Manager interface down here to fetch the private key, just because it's nice. And you should never store private keys and secrets in your code or property files. Now, if we look at the source code itself, it's pretty simple. So this is my Lambda function. It's called payment handler. And you just have to implement the request handler. There are several possibilities here depending on what input you want for your Lambda. So in my case, I'm listening to an SQS event queue, but you can also let Lambdas chain to each other, to an SNS topic, whatever you want. But for us, the SQS event is important. And whenever the Lambda spins up, it will execute this method. Again, this is a predefined method signature, so nothing special there. From the SQS event, we get a list of messages that were put on the queue. So those are the messages that we actually want to process. And a message looks like this. So I configured a test message for you guys. So this is all predefined Amazon stuff. This as well, so not that important. But here we have the message attributes, and that's the part I'm using. So whenever our Lambda gets an SQS message, it expects to find the to and the amount field on the message. And we will be sending money to that account, that public key. And yeah, the amount is the amount. Is that clear? Where were we? Nothing that important here. Okay. So once we parsed all the arguments from the SQS event, we then get into this piece of code that I wrote, which will actually do the blockchain part. So in order for you to send money on a blockchain, you have to have a from account, which is sending the money. You have to have a to account, which you're sending money to. And yeah, you have to have an amount. And the way you work with those accounts is a bit different depending on which type you have. Because the account you're sending money to, you can just use a public key there. But the account you're sending money from, that account has to authorize the transaction on the blockchain. In order for you to authorize a transaction, you have to input your private key. So that's why we're getting the private key from Amazon Secrets Manager here, so we can actually sign the transaction. If you don't sign the transaction, the blockchain will just say, hey, fuck you. Something like that, in a more polite way. So for the transaction itself, this is all just stuff from the Stellar SDK. So these are all methods and objects and classes that are built for you. And they map to the Horizon API. I will show that in a second. So now that we have our accounts, we can start building a transaction right here. We add an operation to it. The operation that we want to do is a payment from the native asset type with the amount that we got from the SQS event. You can add a memo to your transaction, so that's just a text field to say something, have some money bro, whatever. And then important, you have to set a timeout here, because every 5 seconds the blockchain reaches consensus and add blocks. But if your transaction keeps falling out of the priority for that, you might want to cancel it after a while. After all that's done, we just submit the transaction to the Stellar server, and that's defined up here. So the Stellar server is just Horizon behind the scenes. So as you notice, we're using Horizon testnet here. Now, to prove that it actually works, I created 2 wallets on the testnet. So this wallet will be sending money. So the private key of this wallet is in AWS Secrets Manager. And the SQS event that we configured, the test event, has the public key from this wallet, the receiver. So when we then test our Lambda, everything should work, hopefully. So the reason it's taking so long is because the Lambda goes cold after several minutes of inactivity. But apparently it worked, so yay for that. Now, when you look at the details from the execution, you can see that my code logged this statement. We made a payment to this address for 500 stellar. So we can verify that that's all true. So the test event also had this public key, so that seems to be in order. And now when we watch into the wallets, we can see that there is a recent transaction now, have some money bro, to testnet receiver. So that's basically how that works. Now, one last thing I wanted to show you guys, why Horizon is so awesome and cool. This is the transaction hash from your transaction on the blockchain. It's kind of like a unique identifier for your transaction. When you go to Horizon, you have a pretty big API from them. And you can go to the endpoint transactions and give in the hash. And then everything from that transaction will just show here. So the Stellar SDK, what we used in Java to work with the blockchain, actually just composes URLs to REST endpoints from Horizon and marshals those results into objects for you. I think that was the last slide. Okay. Ah yeah. If you have any questions and there's still time, I can answer them now, but I guess we're over time probably. Okay, so I won't be answering questions. But when we're at the bar and I had a beer or 5 or 10, I'm in a good mood, you can come talk to me if you want. Okay? Thanks.